Okay, previously we looked at our series in parallel out. Probably I neglected to highlight my outputs there, that this is our parallel output been done before, but just in case, let's just remind people that we need to show us what is the there. We show the input, there's the output. Nothing stops us also, because we can still get our series output from that last oh, we didn't show. Okay, they are redundant maybe, so maybe that's not an issue, but probably someone would want you to show the node queues. All right, again, the set is redundant, we're not really gonna need it, so but then you know that the actual symbol must indicate it. All right, so probably indicate our series output as well, because we still have it. If we take the output through the queue, it will still be a serial output, but there is what we wanted. They wanted a series input and a parallel output. Now that I've highlighted that, because I neglected to highlight that, now that I have, we can have this one out of the way, and you can say, okay, we don't need this either. All right, so our next project there is looking at parallel in series out. So what I want to look at now is, let's say, how do we read data into a direct? Because parallel in, we're going to need to read them at the same time. We're going to have to drive our input in at the same time. Let me rather have a Q this side, not that it matters, but for consistency, not Q was forgotten before. And then we have our D. Let me have a JK for a change. Let me have a JK for a change. People will start to think that it will start to forget that it can be done with JKs. All right. Again, the clock can either be can either be, if it's a JK that is not a master slave, it will be direct. Let me use master slave for a change. Can't remember what I used last time, but let's use master slave anyway. So remember that it needs to be configured as a D type, so we need to put an inverter between. The inverter is pointing at K. Okay, careful about that. The inverter is actually pointing at K. All right, the little zero is not on top there, it's actually at at K. Our input is on is on J. All right, so what you then do is, we need a way of, if I'm going to read in a 1 directly or a 0 there, I need to be to be setting or resetting. Okay, so if I'm going to want a 1, I'm going to want to set this. If I'm going to want a 0, I'm going to want to reset. Okay, so I want to be able to drive my output same time. All right, my Q same time. Looks a little bit okay. There is a Q. So now what I need to do is, I'm either going to, let's try let's say we try to do that with our previous control. Let's see why. Let's understand why this one would not work. Okay, let's say we tried it with that. What we'll do is, we'll need a control to say fit as in allow. Okay, we'll say fit as in allow, so we're going to say 0 or 1 does the other. Okay, so let's say now, if we use AND gates, okay, the moment we say fit or allow, okay, if we say 0, that 0 will give us 0, that 0 will give us 0 at the same time. What will that mean then? It will mean that it will try to it will drive our gates instantly. Okay, so what we then do is say, okay, we can't then be using be using that. What are we going to use? We're going to use a NAND gate instead. All right, so I wanted that understanding of why we are not using the same control circuit that we started with. Now why we are we are actually using NAND. Okay, so you see that with this one here, we're not going to use the AND, we're going to use the NAND for that reason. Okay, so there is our NAND, and there is our NAND. Because why are we having two? Because we're either going to set or reset. Okay, so now you can see when you use the same control now and say 0, this is just control to allow information through. When you say 0 here, it gives us a 1. Remember, this does not set with the what? This only sets with the what? Sets or resets with the 0. So it does not reset. It will now say, when I have a 0, it will say what? It will say 1. And it leaves it be. If I say again there, it will say 1. As long as there's 0, it will say 1, 1. So nothing happens. If I then say, why am I worried about the 0? Because this gets response to the 0. If you look at the 1 there will simply say what's happening on the other side. Okay, the 1 with the AND gate does not cause it to react instantly. The 0 would have caused, if we had used AND gates here, the zeros would have tried to set and reset at the same time. That is why it's not practical for us to what? It's not practical for us to use our previous gate. So what we then use is the NAND. So we don't have, if it's 1, it says okay, what are the other inputs? If it's 0, the 0 says okay, I drive you same time, and then it tries to set and reset. Because if it was an NAND, with a NAND, 0 will say 1, 1 and do nothing. So let's now go to the other. What are we trying to do? With each gate, we are trying to say, are we setting, are we setting or resetting? Okay, so there we say our set or reset pulse must be different for the two. That's why we have an inverter for the one. If you want to say we want to reset, okay, that becomes a 1. Okay, if we want to say, and that becomes a what? A 0. And this one is blocked already, because remember, the moment you put an end on end, the moment you put a 0, you are ignoring the other what? The other input. Okay, so with a 0, that one becomes a 1, nothing happens. With that one there, it becomes a 1. But let's see now. Let's suppose our control, this is the control, by the way, I did not mention that this is the control. Let's say our control is on 0, then this is 0, this is 0. Okay, 0, 0 says what? It says 1. Okay, on an end it says 1, meaning nothing happens. But 0 there becomes what? Becomes a 1. And then remember, the 0 is blocking, so 0 says hold on. Okay, 0 is like hold. With a 0, let's say 0, let me not put it like this because it becomes unclear. Let me rather do it the same way I did there. So 0 is going to be a block. We know that inputs that immediately give us outputs without worrying about the others are what? Are blocks. So 0 is block. Okay, and then 1 is load or allow. Load, I prefer load in this case. Load or allow. All right. Okay, so now when you then go to 0 will block, was this will immediately say 1, that 0 will say 1, so nothing happens. 0 on that will say 1, 1, and then it means nothing happens, whatever that is. But now I change and I say 1 on the what? On the control. I change and I say 1 on the control, and that says you are opening both gates for our input. Now this 0 there becomes a 1 there. That 0 there says we are still a 1 here, so nothing happens. But that one there becomes 1, 1, 1, 1 becomes a 0, and voila, that guy goes to 0, because the 0 is our signal to what? To set or reset. So the 0 came to the reset side. Let's suppose we wanted to load a 1. If we wanted to load a 1, this would be a 1, and obviously this is no longer true. This is no longer true. This is no longer true. Let's start with the first scenario. This is no longer true. Okay, again The 0 will block, will give us 1 there and 1 there, so it's block. We've explained that. Now the 1 here says, okay, what are we trying to do? Says we are trying to set, we are trying to load the 1. That's why I called it load. Try to load the 1. Now that says not here though, here. Alright, that 0 says keeps that the 1 and is blocked, and 1 1 says 0 here, and 0 is saying, oh, okay, what are we doing here? We remember we set and reset with the 0. Says no, we are not resetting, instead we are setting. So the what, our signal comes to what, our Q is driven to a 1. So this is how we can directly feed the what, directly feed our JK or our D-type flip-flops, whatever. This is how we can directly fit our shift register. So what we then do is we then combine this. Now that we know this, what do we do? Let me take this. Hopefully people understood this. Let me rather remove it once and go to my circuit. So what do we have? I'm gonna use JKs to be consistent. I could use this, it's easier. It's equally easy with JK, but there are certain things to watch out for. Okay, so it's JK. Nothing stops us from drawing the other way. Just that I've been doing it like this, so I just want to be consistent. Nothing stops us from drawing in the other direction, from having the J's on this side. Someone looks in the mirror, is still them, right? So I'm gonna use what? I'm gonna use master slave, master slave, master slave, and master slave. Okay, but I'm gonna remember that the first one, my input side, I need what? So the clock is a shift register, so our clock is still common, that doesn't change. That part is still common, okay? So this is still a common clock, and it's a master slave, so we show that the triggering or the flip-flop will open on the what? Will open on the leading, no, trailing edge. So it's a master slave trailing edge, and to configure this as a D, we need that for that one. But for the rest of them, we will not. We are shifting, so that one will fit that one. But remember, the inverse can be taken there. I don't have to do this again there. Again, so for the same reason here, this one will fit the next one. That one will fit its own. And we've got our Q's, not Q's, which is how we avoided having to use inverters all the time, because Q and not Q are already inverting each other. So this here is our output, and output. All right, but let me start with the what? Let me start with the series out. The series out is gonna worry about this output only. Series, I'm doing series out, series out. Okay. Okay. So now what then happens is that the series output is gonna come out there. What I need to do is I need to decide here for each one to either I'm setting, and I explain why in this case we cannot use AND gates. The 0 will immediately try to set and reset both. So each one will need 2 NAND gates, one for the ability to set, the other for the ability to reset. Reset, set. Reset and set. Probably gonna have to move the traffic there. So these are NAND gates. Okay, so that one goes to that guy, so reset. The other one goes to the other end, set. Reset, set, reset, set, reset, set, and reset. And they're all with zeros. Okay. A pair each, a pair of NAND gates each to set, and I'm gonna need to remove the traffic here. A pair each for set and reset, and it's a pair of NAND gates. For a NAND gate to go to 0, it needs a 1, so I need a, for that reason, I'm gonna take the controls to the left because I'm out of space that side. That's the only reason. This is for opening or blocking. Okay, so I'm gonna take trying to be okay. I'm gonna load or hold. I'm gonna call it load or hold. Okay, so here this is 0. This is the control. 0 you hold because 0, and then the 1 you load because 0 will automatically drive the gate ignoring the other part. So that is the whole part, that is the whole function. But for all that go to the what, to the reset, I need them to go through a what, an inverter, because a 0 then needs to be a 1 here. So at 1 and 1, this gate will give us 0 with 1s only. So I need 0s here to be changed to 1s for the reset line, not for the set line. So here for that reason the inverter is needed on the reset line, because if we're going to drive this, going to be a 1 to give us a 0, so that needs to a 0 to do that. So we're going to need a what, an inverter on the reset line. Okay, so now this is our inputs. Okay, this here probably I'll take it up. This will be our parallel inputs, but what they do to the one, the opposite must be done to the other. If you are resetting, they must make sure we don't set. So 0 will block this one. 0 will block the what? The set line. 1 will open, because 1 looks out for the other gate, so 1 will open the set line. That's the reason we need an inverter to be on the reset line. So now I'm done with my circuit. I don't want to make the same, to be as careless as I was previously, to forget to actually indicate that this here is our parallel input. Okay, that's our series output. Nothing stops us here from having what? A series input. We're still able to feed in series this side. So this is our series input. Alright, so I've explained how you can load. If I had, in any space where I had zeros, if I had 1 0 1 0, you can see how that 0 will block, that 1 sorry will block that gate. That 0 will block this gate. All the gates with zeros that I'm putting zeros, but that one will block that gate. That one will block this gate. What's happening here is the line that is blocked is the reset line. The line, because we are setting, the line that is blocked is the set line, because we are resetting. The line that is blocked is the reset line, because we are, 1 is a set. The line that is blocked is the set line, because 0 is a reset. Okay, to load a 0 we need a what? A reset. So now we can immediately say when you block that line there will be open. Now 0 volt will block everything. When you put on 1, every gate is open, but those are already blocked. So if this one is open, it's 1 and 1, that will be a 0, that will be what? Driven to a 1. If it's 0 there, that one is blocked. But remember, we've said this to load, so this one is a 1. It's load is a 1 1 1. That will be a 0 here. This will be reset. That there, for the same reason as the first one, the 0 there is actually blocking that, but the 1 is saying I'm here, but we're on load, so it's 1 1, and this says we are is 0, and this says we are setting. And the final one says 0, that one is blocked, but that one says I'm a 1, but it's on load, it's 1 1, again it says 0 here, and this says reset, and we have what? This, the status of this one being on what? On 0. And we've read our data at the same time. We've read it in parallel. So reading in parallel the same way as loading in parallel, the same as taking our output in parallel, is faster than what? Than doing things in series. Okay, so that means parallel, any parallel injection or any parallel extraction is actually faster than this what? This series equivalent. All right, so this is basically, I wanted to use, we've been using what called this D-type flip-flops. I wanted to use JK, but the reminder is that this must be what? Set to what? To D-type. Okay, so it can just pass data. So that also must what? That also must be set to what? To D-type. This one is easy. We didn't have to what? To use an inverter, because these two, I neglected to put my Q and not Q there. They are already opposites and they're doing that job. So same as the other one, same as the other one. So they're all set as what? As D-types. So this is basically how we would what? We would actually achieve parallel in. Okay, and our series output. Now after we've loaded, which will be at one go, we'll say load, and all the information that is waiting there goes through. Now we can shift a clock pulse at a time. All right, and then we get our what? Our parallel output. I hope that was not complicated. I won't have to. I think my last session will be very short, because I won't have to what? I won't have to explain much. Most of the things are done already. So With that being said, let's meet when we are doing what? When we are doing the last bit, which is the parallel in, parallel out. Ciao.